Today, we are diving into a scientific detective story. It's about a world so bizarre, so strange, that when the news first broke, it captured headlines all over the globe. We're talking about an exoplanet, about 40 light years away, that scientists once thought could literally be made of diamond.
This was the bombshell claim from back in 2012. I mean, just try to picture that for a second. A world where you're not walking on rock and soil, but on graphite, and where the mountains might actually be made of pure diamond. It was an absolutely stunning idea that made everyone rethink what a planet could even be.
But here's the big question. Is it true? Could a planet really form in such a way that a huge chunk of it is pure diamond? That's the mystery we're going to unravel today. We're going to follow the clues, just like scientists have, as they peel back the layers on this incredible cosmic case.
So here's how we're going to do it. First, we'll look at that sensational original discovery. Then we'll properly meet our prime suspect, the planet 55 Cancri Ae. We'll get into the science behind the whole carbon planet theory, and then, this is the fun part, we'll see how new clues have completely flipped the story on its head and revealed why this world is maybe more important than we ever thought.
Okay, so let's rewind the clock to 2012. The entire astronomy world was absolutely buzzing about a newly characterized planet that just didn't fit the mold for any rocky world we'd ever seen. The study that came out was a real game changer. Based on the planet's size, its mass, and what they knew about its parent star's chemistry, their models all pointed to one unbelievable conclusion. About a third of the planet's entire mass, that's the equivalent of 3 whole Earths, could be solid diamond.
So who is this planet at the heart of our story? Let's get formally introduced to our main character, 55 Cancri Ae. First up, where is it? Well, cosmically speaking, it's practically our neighbor, just 40 light years away in the constellation of Cancer. That's actually close enough that its parent star is visible to the naked eye, if you know exactly where you're looking.
Now, this is where you really see just how extreme this world is. Sure, we call it a super Earth, but compared to our home, it's twice as wide but a whopping 8 times more massive. A year there isn't 365 days, it's 18 hours. And the surface temperature was thought to be a blistering 3,900 degrees Fahrenheit, hot enough to melt rock. This thing is no Earth twin, that's for sure.
So, the big question is, how do you get from those wild stats to the idea of a diamond planet? Well, it all comes down to some really fascinating theoretical science.
The whole theory hinged on this idea of a carbon planet. See, Earth is oxygen-rich, so our rocks are made of silicates. But the hypothesis was, what if a planet formed in a system that had more carbon than oxygen? Well, then the fundamental chemistry would be completely different. You'd get a world built not from silicates, but from carbon compounds.
And this is what they thought the inside of 55 Cancri Ae looked like. You've got a normal iron core right in the middle, but then it gets weird. They figured that above a thin silicate layer, the insane pressures and carbon-rich chemistry would create a massive planet-wide layer of diamond, all topped off with a surface made of graphite.
For years, this was the leading story for 55 Cancri Ae. It was incredible, but, science never sleeps. As our technology got better, new clues started popping up, and our sparkling diamond planet, well, it started to look a little different.
This timeline really shows you how science actually works, right? An idea is proposed in 2012, a really compelling one. But over the next decade, other studies started to find little holes in the theory. And then 2024 happened. The James Webb Space Telescope, the most powerful scope we've ever built, turned its eye to the planet, and it changed everything.
And here it is, the first huge clue from Webb. The old model said the planet's day side should be roasting at over 4,000 degrees Fahrenheit. But Webb measured it, and it was only 2,800 degrees. Now look, 2,800 degrees is still ridiculously hot, but that 1,200-degree difference, that is a massive clue that something was wrong with the old theory.
So what could possibly explain that cooling effect? Well, the best answer by far is an atmosphere. Some kind of thick gas, has to be there, grabbing heat from the side that's always facing the star and circulating it around to the dark, cooler side. A bare chunk of rock just can't move heat around that efficiently.
And Webb didn't just guess there was an atmosphere, it found the smoking gun. By looking at the light coming from the planet, it saw this very specific dip in the spectrum. That dip is basically a chemical fingerprint. It's the telltale sign of a gas like carbon monoxide or carbon dioxide absorbing certain colors of light. The atmosphere was real.
You have to imagine what a huge moment this was for the scientists who'd been wrestling with this mystery for years. You can just feel the excitement and the relief in this quote. After more than a decade of frustrating questions, they were finally getting some real answers.
So, if it's not a diamond planet, then what is it? Well, the debate is still going on. One of the competing ideas is that instead of being super rich in carbon, the planet might be rich in aluminum oxides. And you know what those are? They're the building blocks of gemstones like rubies and sapphires. So the story just keeps getting stranger.
So, okay, the diamond planet might be off the table. But the true story of 55 Cancri Ae that's emerging, it's arguably even more fascinating, and it's teaching us so much more about how planets actually work.
The data from Webb suggests this planet has something called a secondary atmosphere. Because it's so hot and getting blasted by its star, any atmosphere it was born with should have been stripped away ages ago. So the atmosphere we're seeing today must be actively bubbling up from the planet's interior, likely from a vast, molten ocean of magma covering the entire surface.
So what are the big takeaways here? What have we learned? First, this whole story shows that science is a process. It's not a set of facts, it's a method of constant revision and improvement. Second, it proves that planets are way more diverse than we ever imagined, and that even super hot rocky worlds can hold on to atmospheres. And maybe most exciting of all, studying this active magma world could be like looking through a time machine into our own planet's distant past, back when Earth too was a molten ball of rock.
And that really leaves us with one final, amazing thought. The story of 55 Cancri Ae has been a wild journey, from a sci-fi diamond world to a scientifically rich volcanic world. And it just makes you wonder, if one planet's story can change this dramatically, what other unbelievable exotic worlds are out there, just waiting for us to discover them?